you remember that A1 and A2, if you can remember in the previous class, for the thing we talked about, that I have this probability of Z given S1 and probability of Z given S2 for AWGN case. So if I put this thing that is greater than equal to this term and this term, that means that sigma 0 root 2 pi gone, e to the power gone, minus half 1, that is Z minus A1 by 6, sigma 0 is also 1, Z minus A1 whole square by Z minus A2 whole square type of things will be on represent. So here let us see that what is present over here. So yes, it is some Z and A1 and A2. So if you play with the equation little bit, you will find that your maximum likelihood receiver structure, that means decide S equal to S1, that means the rule is decide S equal to S1. When the maximum likelihood receiver structure means this PS1 equal to this, probabilities are equal, which is quite natural until and unless stated otherwise, that if ZT greater than A1 plus A2 by 2, which is equal to, say, I am just using a gamma 0, decide S equal to S to the other symbol if ZT, that means what is ZT? ZT, if you remember, that means this is the ZT, that means this ZT that you are choosing, that you are choosing, that threshold comparison gamma is that A1 plus A2 by 2. Okay. That this ZT and this, and if you see, that means this A1 plus A2 by 2 is the optimum threshold for minimizing the probability of making incorrect decision for an important special case. Special case means PS1 equal to PS2. This is called the probability of, the strategy is called minimum error criteria. Please remember that is, please try to derive it, why it is called the optimum threshold, why the minimum error criteria. Okay, it's quite simple, because in machine learning class you may have studied this thing, the similar type of thing, maximum likelihood, and that finally it is that PZ that I told, that PZ given S1 greater than PZ given S2, that is the decide S1. That they have done, that PZ given S1, PZ given S2, detector chooses S1 if PZ given S1, otherwise the detector chooses S2. That is called the maximum likelihood detector. What I explained to you. Okay. Now what about the error probability? Okay, for binary decision making in figure 3.2, what is figure 3.2? Let us see what is figure 3.2. It is 3.6, 3.3. That is all. This is the figure 3.1. This is your figure 3.2. This is a quite celebrated picture. That means that you are choosing now that what is my, if I take the picture now for the maximum likelihood structure, what we have seen, that for optimum threshold, so I will have the value of ZT somewhere here. Okay, I am receiving when ZT equal to, this is my A1 and this is my A2. Now this is my A2 and A1 plus A2 by 2, that is your gamma 0. That means I am checking that whether ZT is greater than gamma 0 or ZT less than gamma 0. If ZT greater than gamma 0, then I am saying it is S1 is transmitted, that means ZT greater than gamma 0. Here somewhere, if ZT I am receiving on this side of the signal, then I am saying, oh, actually the S equal to S1 is transmitted. But when Z equal to ZT less than S gamma 0, that means S1 A1 plus A2 by 2, that means this side of the signal, then I am saying no, actually S2 is transmitted. This is S1 is decide. But what is the problem in this? The problem that you know that those type 1 error, type 2 error, that means probability of probability of false null hypothesis and probability of true alternative hypothesis kind of thing. That is H1 or H0 and H1. That means, say, though you are receiving this, the value of ZAT or ZT, say some A somewhere here. That means you are getting this value. You are saying, okay, so that means you have got this ZT is ZAT. You have got this one. So you are quite well. You have decided that, oh, this is actually from JS1 is transmitted. Okay. And but then you try to understand that, but actually it may be from this side, it may be from this distribution, but it is a bit far out. So that means then what about the error you will commit? That is, if it is actually from this side, the probability of detection is called this is called probability of detection. And what about the false alarm? This is from here. What is my error? The error is basically this side. Okay. So, sorry. Probability of false alarm is this, because actually it has come from this. Okay. So that means this is the error. Similarly, if you choose from this side, then actually error is it has come from this one. So if you have like this, actually it has come from this thing. So error is this part, and the right thing is basically this one. Okay, the probability of detection. Okay, now. So these we are going to discuss error probability. Now the error probability, that means an error will be occurring when S1 is sent, channel noise results, the output ZT being less than gamma G. Means when the error will be there occurred. Actually S1 is sent and you have to detect S1. But in order to detect the S1, that means your ZT value should be probability of Z given S1 should be greater than PZ S2, or rather when you will choose S1, that means when you will choose H1, that is when your ZT is greater than gamma 0. But actually it has become ZT being less than gamma 0. Now that means the ZT become less than gamma 0. So what is that probability of Z given Z less than gamma 0? Let us see what is the probability. Probability of Z less than gamma 0. Okay. So, and error has occurred. Error is, so that means actually S equal to S1 is transmitted, but as Z is this side, so you are saying no, and actually Z is was, that's why you have to consider these areas, these shaded areas. So, and in the opposite case, when S equal to S2 is transmitted and that actually that ZT is here, then what is the problem? This will be the error. Okay. Now, for gamma 0 equal to something, that is say some error figure gamma 0. So this is my one side error. This is another side error. This is the probability of error. Okay. Now let us see what is that. That is that probability of Z given S1 dz, and similarly that an error occurs when S2 is sent, the channel noise results ZT being greater than gamma 0, and probability of this occurrence, probability of B given S2 is probability of H1 that given S2. Actually S2 is sent, but you are choosing H1 depending on your ZT value. That is PZ given S2 and DZ. Okay. So that we were talking about. I just shaded those things. Now, what is the error probability? Error probability is these probabilities are independent and they are mutually exclusive. So you are just adding these two, and probability of E given S1 plus PSI. That probability of beta error is E given S1 PS1, E given S2 PS2. But A given S1 is PH2 given S1, and P given S2 is PH1 given S2. Okay. Now this is my probability of beat error. Okay. Now the question is that when PS1 equal to PS2, when PS1 equal to, that is we are talking about mainly ML estimate, then your PB probability of beat error is half of P of H2 given S1, P of H1 given S2. Okay, because of the symmetry. Now, but PH1 given S2 and so PB PS1 equal to PS2, so I am putting a half and half. But I told that probability density function is symmetric. That means that PH2 given S1 and PH1 given S2. Let us see. This one is PH2 given S1. PH2 given S1. And this one is PH1. Sorry, this is PH1 given S2, because actually you are taking under this curve, that is actually S2 is transmitted, and you are taking PH2 given S1. Okay, actually S1 is transmitted, and but you are actually S1 is transmitted, but you are choosing one this. So now, and please see, this portion and this portion is symmetric for your this here. So then this area is equal to this area. Red area and black area, they are same. Now as it is symmetry, so PB equal to, that means this term and this term same. So I have that 1 into PH2 given S1 or PH1 given S2. That probability of beat error is this. Now that is area under the tail of either likelihood function. That is falling on the incorrect side of the threshold. Now what is my, so the probability of is numerically equal to the area under the tail of either likelihood function Pz1 Z given S1 or Pz given S2 falling on the incorrect side. Now we can therefore compute PB by integrating Pz given S1 between the limit gamma minus infinity to gamma 0. Okay, the integrating Pz given S1 minus infinity to gamma 0. That Pz given S1, okay, from minus infinity to gamma 0, from minus infinity up to gamma 0. Similarly, you have to Pz given S2, you have to integrate from gamma 0 to plus infinity. If you check these two figures side by side, then it will be easier for you. And finally, that it is probability of beat error is basically, if you just integrate everything, finally it will be that gamma 0 will be the optimum threshold. Okay. And that finally, if you play a little bit with it, the QX is called, now you will find that if they will play with these things, and they will just standard that Z minus A2, Z minus mean by sigma. That standard normalization people do to do these operations. And you see that there's a Q function they use. That Q, what is my Q function? Q function is called, Qx is called complementary error function or co-error function. Now, Qx is that defined is for Gaussian. Okay. That is probability under the tail of the Gaussian period. This is defined as, see, Qx is approximately defined as, please try to. 1 by root 2 pi. I don't know why they have written approximate. So it is x, that is right hand probability, that means x to infinity. So it is like that. I have a distribution. Now this is my x. Ux is basically this one. This is called the right side probability. Sometimes your co-error function. That means 1 minus fx. Okay. So 1 minus cumulative function. Okay. Anyway, but Qx cannot be, please remember, Qx cannot be evaluated in closed form, because see, if I give you x, you cannot just calculate Qx, because you have the integration, you have to calculate this area, and which cannot be calculated in a closed form. But there are certain very good approximations. Please read these approximations. It is given that in some, if you just do Google it, you will find, or in reference 5, say one such approximation for valid x greater than 3. Please remember, these Qx is defined for this one where this Q is a normal distribution with 0 and 1. Okay, and Qx is defined for that. Okay, please remember that Qx is defined for standard normal variant. Okay, and when x is greater than 3, that means that side, that means almost say this is your 1, this is 2. That means beyond 98.7, 99.78% and all these things. That if it is x greater than 3, please try to understand. Okay, say 1 is like this. Okay, but there are certain other approximations. Please read those approximations. See, I'm not going into details, and this up to, so this is the, because you from that Qx, basically your probability of beat error is basically Q of A1 minus A2 by 2 sigma. Okay, that means I have a like this, say the Gaussian. Now this is your A1 minus A2 by 2 sigma 0. Okay, and the error is basically A1 minus A2. Error is this area, probability of beat. Now the question is that I have not actually covered why this gamma 0 is called. You see that there I have defined, just said that why this particular gamma 0 is called optimum threshold. Why the name optimum? Okay, that means my question is that why this particular gamma 0 is called optimum? Because why my question is, that means say I can choose my another threshold over here. Okay. That means this is my say gamma 0 prime, and I am trying to do zt greater than gamma 0 prime and all these things. Now in that case, what will be my error? The error on this side error will be like this, and that side error, the probability of beat error, that will be like this. Now optimum threshold means that is this total, that means that red and this area and this blue area. Okay, that you have to minimize. Okay, that is, this is your probability of beat error is sum of these two areas. Now this gamma is called optimum. This gamma means when that if you choose gamma equal to gamma 0, then your this area will be minimum. And we have seen that if you choose gamma means if you don't choose this intersection point, okay, if you choose anything other than this intersection point, this probability of the sum of areas will be more, and in that case that is suboptimal. So that means this is the probability of minimum beat error, minimum probability of beat error. and that is my gamma 0. But I have not proved it. So you should prove it. You should prove it. Please remember, this is a very important point, but this is quite common because if you play a little bit with it, you will get this thing. Okay. So why the name it is? Why it is optimum? So that's why that gamma 0 is called optimum threshold. Okay. So many a times you will find that we are talking about. See, here also we are talking about optimum threshold, minimum error criteria. See, this strategy is known as the minimum error criteria. And please choose that PS1 equal to PS2. Okay. And so let us stop here. Okay. And up to this portion, that means how we are doing the detection, up to this portion is our syllabus of the class. Okay. So because there are some students who wrote me an email that what is the syllabus? Syllabus is up to this for class test. Now for the schedule test again we'll go to the max filter. Okay, max filter means, if you can remember why suddenly max filter came into picture. That max filter is basically that we'll talk about here. That means here where the max filter is required and all these things. Max filter, equalizing means receiving filter is, we'll see that is where somewhere, and also we'll study the equalizing filter. So we'll discuss those things here after that, because Thursday I cannot take class, but Friday during class hour the class test will be taken. You have to solve the problem. You have to I will share the Google Drive and all these things. I will share the Google form and you have to upload your answers to there. Okay. Thank you.
Sir,
Yes.
sir, if you could just tell from which book which chapter is there, because when you were teaching it was a bit
No,
random.
whenever I taught, I am teaching from the book, and I have categorically every time I have told this is from this book, this is from this book. Now I will not say, because
Sir,
those who
and
are attending classes, they will know.
sir, and can you send some tutorial sheet also
No,
for
I
practice?
will not. At this last stage, I will not send anything. This I expected. Means maybe 2 weeks back kind of thing. When I was discussing that time also, and now you cannot claim many things. You study things. Okay. Please do the deduction. Please solve problem. That much maximum at this point I can say. Thank you very much.